question 13. So for any vectors u and v in V3, or the set of all points in 3 dimensions, we have the statement u cross v dot u equals to 0. So now we're doing a dot product of a cross product, and we have the u are the same. So u and u there, and this equals 0. And this is actually true. So this is true because the cross product right here gives a vector that is perpendicular to both vectors. So this is perpendicular to u and v. And the dot product between the cross product and one of its vectors is equal to 0 if they are perpendicular to each other, which they are. So cross product is so cross product gives a perpendicular vector. So then this one right here is perpendicular to u and v, and now we're doing a dot product with this perpendicular vector to u, and these are perpendiculars. And so if you have, we'll call this, let's say call this w. So we're going to have w is perpendicular to u, so w dot u has to equal to 0 because it's perpendicular. So that is the case there. And there's links to my earlier videos. And there's a dot product right here. So a dot b, because remember it equals to that cosine there. Right there. So if you put cosine pi over 2 or 90 degrees, this goes to 0, and that so then this would all equal 0. So for perpendicular vectors, that is 0, and also for my other video there on a cross product, so a dot b and then dot a or dot b is equal to 0 there. And we can see this is true by computing the scalar triple product. So again, link to that. There's scalar triple product right here, and let's solve this. Just as an exercise there. It's pretty interesting. So let's just get some derivations or proofs in this video, as opposed to just reading my earlier video. So let's go u. So we'll have u cross v dot u. So that is what we were asked. So right here, show that it's equal to 0. Well, we already just went over that, so that is true. It equals 0. And let's just show it quickly in the using the scalar triple product. And this right here, first of all, this one here, we already went over the identity. This just equals to u dot u cross v. So it doesn't matter which order you write it, it's going to be the same thing. And here, quickly teleported. This is the question 11. This one we already showed that it's true there. So u dot v cross w equals to u cross v dot w. So in our case, we have u there. The w is equal to u vector. So we can just interchange them. And reason we're doing that, so we can now write this as a giant right here. This is going to equal to u. It's going to be u1. Let's just say it's in 3 dimensions. So u1, u2, u3, and then put this all as a scalar triple product format, determinant format. And v1, it's still u actually. So it's still u1, u2, u3, and then v1, v2, v3, like that. So that's what we have. And now what we could do is this equals 2, and again the same setup. I'm going to make this giant. Actually, it's not going to be too big. I'll just make it like this. Equals 2. So we have u1 times it by, and now this is, we cross this out, and this, and the same thing, u2 times v3 minus u3 times v2. Now subtract by, and now we do, instead of the ijk, we do the other setup. So we do this one, u2, and cross this out, So u1 times, this is going to be u1 times v3 minus u3 times v1. Now the next setup plus, erase this and this. So this one here, u3 times it by, and now we cross this out, u1 times v2 minus, so u1 minus u2 v1, like that. Make sure to make it more pointy. So that's what we have. And what we'll do is now just multiply these all in. This is going to equal to u1 u2 v3 minus u1 u3 v2. Next setup here, I'm going to write these in order so it all looks like it. So u2 minus inside, but we'll put the u1 in front. u1 u2 v3, and then minus becomes plus. u2, u3, v1 plus, now this one here is going to be, put the u1 in front, u1, u3, v2 minus, now u2, u3, v1. That's what we all have, and we can see it just cancel like terms out. So this one, u1, u2, cancels with this one here, u1, u2, v3. Now this next one is going to be u1, u3, find another u1, u3. Yeah, so this one, negative u1, u3, v2. There's a positive u1, u3, v2. And then I think we have, I forgot to cancel this one out. Yeah, so this one is u1, u3, v2. This was negative u1, u3, and v2. And the last one, u2, u3, v1, u2, u3, v1, and negative sign. So there, that's all equals to 0. So this is true. So let's put an arrow, true, like that. Alright, so now let's take a look at question 14. So for any vectors u and v in V3, or the set of all points in 3 dimensions, we have the bracket u plus v, then cross product with v right here, and this equals to just u cross v. And the solution to this is, well, this is actually true, and the reason is, we can see this right here, u plus v, we could actually multiply this inside and do it separately. Yes, we could do the cross product separately of u and v, so then we're going to have a u cross v set up there, and that actually goes to 0. So this is true because of the distributive property of the cross product, and this is actually question, I think 11 or something, I think 11 or 10. Yeah, we have it. Question 10. So question 10, we went over this one here. U plus V cross W is the same thing as writing U cross W plus V cross W there. So you can just multiply it inside, just like simple addition and multiplication. Yeah, and here I just put question 10 there. So this is true because of the distributive property of the cross product, question 10, and that the cross product of a vector with itself is equal to 0. There's a link to my earlier video on that. It's pretty straightforward. So the cross product is it gives you a perpendicular vector, but if you put and it's also has a sine function there for the magnitude of it. But when this angle is 0, then the actual cross product goes to 0. So non-zero vectors a and b are parallel if and only if a cross b is equal to 0. Yeah, so they're parallel when these are directly on them. And then the cross product gives a 0 there. And we can here quickly teleport to question 4 where we showed the length of cross product. Yeah, there's a sign there. So if sign is 0, then the whole thing, the length is going to be 0. And so we just get a 0 vector there. Alright, so this is what we have here. Now we could draw this out just to illustrate this here so we can evaluate this there. So what we have is, so if we have u plus v, and then cross v, this just equals to, using the distributive property, this equals to multiply that inside u cross v plus, and then v cross itself. And now this part right here, this goes to 0. So in other words, this becomes u cross v. And this is exactly what we had over here. So we get, u cross v. So this is true right there. Yeah, I'll just put a true there.